Frequency modulation 89.8 MHz. Kilo Charlie Alpha Foxtrot. KCAF. Eugene Springfield Corvallis Albany. Whomever solves the problem in the description of our latest YouTube video will get a free trip somewhere. And now back to our scheduled music programming. So before we start, here's a picture of what the problem basically looks like. So for part A, we have to find the wavelength. And then here's the fundamental equation for frequency relative to wavelengths. But in this case, the speed of light replaces velocity. So the speed of light is constant, which is 300 million meters per second. Now we multiply both sides by lambda and divide both sides by frequency. So plug in 300 million meters per second for C. And then for F, we are given that it's 89.9 megahertz. It's actually 89.8, but in the States, the last digit, which is the digit after the decimal point, is an odd number. So, but in this case, it's 89.8, which doesn't really make sense. Probably makes sense in other countries, but not in the States. But yeah, but we have to convert megahertz to hertz, and all you have to do is multiply by a million. So it's 89 million and 8,000. So divide that from 300 million, and then you get 3.34 meters as the wavelength. So that's your answer, right? And now we have to find all the minima. So first we have to isolate theta from the equation. From this equation, d sine theta equals 2n plus 1 in parentheses times lambda divided by 2. That is the order, and lambda is the wavelength. We calculated wavelength, so yeah. So divide both sides by d, and then get the arc side of both sides to take away the sine to isolate theta. So it's just arc side of this conglomeration. And now we have to find all the angles of the minima. So theta of the minima will equal the arc side of 2n plus 1 times lambda divided by 2e. And when you calculate it, for the sake of your kneecap privileges, your calculator has to be in radians, okay? Okay? And we can plug in any whole number, which is basically 0 plus all the positive numbers. So and is an element of whole numbers. So first we can plug in 0 for n. So that just isolates it to lambda. So we can plug in 8 meters for these. That's how it is. So just 16 in the denominator. Lambda is 3.34 as we calculated earlier. So and now you get the answer to that, and then the answer to 3.34 divided by 16, and then get the arc side of that answer. So you get 0.29. But since we're getting all the angles of maxima, we have to include this 2 pi times any number radians. So the answer at n equals 0 is 0.29 plus 2 pi k radians. That's for n equals 0. For n equals 1, you can just plug in 1 for n, and plug in the other numbers for lambda and d. So you get 0.673 plus 2 pi k radians. Usually they use n, but n is already being used in this equation for the order. So now we have to find the maximum for part C. So if you remember your theta for step 1, then you can use it for parts. You can use it for part C, except n is by itself. There's no 2n plus 1. It's just n. So d is 8. So 8 times 2 is 16. So you can just get that down. But this time, since we are looking for the maxima, n is actually an element of all natural numbers. So you can just plug in 1 for n, and then plug in lambda, 3.34, and then just get the arc side of that answer. So yeah, you get 0.209 plus 2 pi k radians for the maxima at n equals 1. And then you can do the same thing for n equals 2. So that's 0.429 2 pi k radians. Congratulations, Raymond. You won a free trip. You are going to Brazil.